Hey guys, this is Zoe. I have all my notes out. I'm gonna explain to you the process of electron transport chain and the reactions that occur in it. So I have my little picture drawn here. So I need to first talk about what the electron transport chain consists of and where it occurs. So the electron transport chain occurs here in the inner mitochondrial membrane. And then what it consists of, it starts off with NADH and FADH2, which are the products from the previous cycle, which was the Krebs cycle. It also includes electron carrier molecules, which are embedded in the inner mitochondrial membrane, the ATP synthase, which is the big mechanism which helps create and synthesize ATP. And you also need to know that oxygen, right here, really important. Oxygen is the final electron acceptor in the electron transport chain. Electron transport chain, so it's transporting electrons along a chain. It kind of looks like a chain. So first, NADH and FADH2 donate their electrons to the electron carrier molecules. So these electron carrier molecules accept these NADH and FADH2 electrons and also take off those hydrogens at the end. So NADH turns into NAD and FADH turns into FAD. And where do those hydrogens go? Well, those H protons are pumped by those electron carrier molecules through the inner mitochondrial membrane into the intermembrane space. So as you can see, the arrows of these electron carrier molecules are signifying the H protons being pumped out of the matrix here. So all the H's are getting pumped because they're accepting the electrons and passing it down from electron carrier molecule to the next one, which is electron transport chain. They're transporting electrons from one carrier molecule to the next. This is the electron flow. Electrons get transported from this carrier molecule, then to this one, then to this one, and then to this one, and then finally the electrons are all dropped off to the final electron acceptor, which is oxygen. So here oxygen combines with and takes in those electrons, combines with the H protons, because there's still H protons floating here in the matrix. There's just a higher concentration here in the intermembrane space than the matrix. So anyway, the oxygen combines with the hydrogen and those electrons and produces water. So what's going on over here in the intermembrane space? So there's a high concentration of H protons here. So these, there's a proton gradient. So high concentration, low concentration. They want to bring itself, the membranes to equilibrium, so they want to rush back inside to the matrix. So where they can't go this way, the only way they can get back into the matrix is through the ATP synthase. So the H protons, see all these H protons here? They're rushing into the ATP synthase. And think of this ATP synthase as a generator. And the H's pump through the ATP synthase. So spinning, making energy. ATP is synthesized here. And the process of ATP synthesis can also be referred to as chemiosmosis. Chemiosmosis refers to the pumping of the H protons across the membrane through ATP synthase to drive cellular work. And the cellular work here is creating ATP. Oxidative phosphorylation is, so in the electron transport chain, energy from the redox reactions, which is these carrier molecules accepting electrons, and while they're accepting electrons, they're also pumping out these H protons, remember, through the membrane. And this proton gradient pushes the high to low concentration. Remember, pumping this ATP synthase phosphorylates ADP to ATP. Another one of the terms that were on the list was cristae. So cristae is basically just the folds in the inner mitochondrial membrane, and that the folds just allow for more surface area. Another one of the terms on the list were pyruvate, acetyl-CoA, and substrate level phosphorylation. In cellular respiration, there are 3 steps. First one is glycolysis. Second one is the Krebs cycle. And the third one is electron transport chain. And remember, the goal here is basically to make ATP. Acetyl-CoA is one of the starting molecules for the Krebs cycle, so that doesn't really pertain to the electron transport chain. Pyruvate is the product of glycolysis, and substrate level phosphorylation, it doesn't occur here because substrate level phosphorylation is the transfer of inorganic phosphorus from an inorganic molecule, and that occurs in glycolysis in the Krebs cycle, but not in electron transport chain. Also, glucose is important because it's one of the starting molecules in glycolysis, and that's not really included in the electron transport chain. And I think that's everything.